Hello and welcome to a new session for this ongoing online course on Introduction to Embedded System Design. I am your instructor Dhananjay Gadre, and in this session I will be talking about how to connect additional output devices for human interaction, namely the liquid crystal display. So, liquid crystal displays are commonly called as LCD outputs, and we are going to talk about how to connect them to our favorite MSP430 microcontroller. Now, you would have seen LCD displays commonly around you in many of the gadgets that you use on a regular basis. For example, on your calculator, on your especially the AC remote and so on. And these are common output devices because they allow very low power operation. These liquid crystal displays come in various types. The simplest one are called numeric displays, and these are the ones which are used in calculators. The numeric displays will allow you to display information in 7 segment format like you have seen for 7 segment displays which use LEDs, but you have the same format for LCD also. So, you would have seen this on calculators. Similarly, the 7 segment display is not able to display a variety of information, and so you have another type of output configuration which is called alphanumeric display, which is similar to the numeric display except it has additional segments, and a typical alphanumeric display will look like this. Something like this. This allows you to display alphabetical characters with little more clarity than is possible with the numeric displays. Then the third type of liquid crystal displays which are common are called character LCD displays, in which you can display ASCII characters in the form of a 5 by 7 or 5 by 8 graphic 5 by 8 matrix of LCD elements, liquid crystal elements. Something like this. Now, on such a matrix you can display almost a large number of alphabets, numbers, special characters and so on and so forth, and that is why these are called character displays. And the most common of the liquid crystal displays is what is called as graphics, in which a row and column full of pixels are available that you can use to create whatever graphical or numeric or alphabetical information that you would like to display. So, these are the common LCD displays that are available. We will now investigate how are LCD displays different from LED displays. And the basic difference is, in a LED display, a LED display emits light. So, it has a source of light, namely the light emitting diode. In the case of LCD, we do not have a mechanism to generate light in a way that a LED does, but a LCD allows you to manipulate light. So, LCD liquid crystal display works by manipulating light. What does it consist of? It consists of several layers of structures. Initially a source of light. The source of light can be ambient light as well as light from a LED source, followed by a polarizer, in which it polarizes the incoming light, say, let us say in the horizontal direction. Then you have the liquid crystal in between, and then you have another polarizer where the polarization happens in the vertical direction. And then of course, here is the human eye, which is able to see what is reaching the human eye. Now, how does it work? If the two polarizers polarize the light in such a way that one is polarizing it in the horizontal direction and the other offers polarization in the vertical direction, no light from the source would reach the human eye. But the intervening liquid crystal has a great ability that once you apply potential to it, it has the ability to twist the light, meaning it has the ability to change the direction of the light which reaches the crystal and change its direction. And if it is aligned to the vertical direction, then that light will come out and you can see it, the human eye can see it. And so LCD is very different from LED. In LED you generate light, whereas in a LCD you manipulate existing light. So this is the basic difference. Because it is not generating any light, it is able to operate at much low power levels compared to a LED display. And that is the reason why LCDs are so common in everyday gadgets for sharing information with the human for human interaction. These liquid crystal displays, especially the so called character LCD displays, we are not going to talk about numeric and alphanumeric, because numeric displays and alphanumeric displays do not have the ability to share too much variety of information. We are going to concentrate on character LCD displays in this lecture, and I will mention what all graphics displays, LCD displays you can have. In a liquid crystal display of the character type, you get it in the form of what is called as 8x1 or 8x2, and these refer to the number of characters in the first instance, and the second information is the how many lines you have. So when I say that I have a 8x1 LCD character display, it means I have one line and each line has and this line has 8 characters. Each character can be any ASCII value, any ASCII character you can display. Similarly, 8x2 would be 2 lines of 8 characters, 16x1, 16x2, these are the most, in fact 16x2 is the most common LCD display that you can find, and in this exercise we are going to use a 16x2 display. Here is an example of a variety of these. This is a 8x2, next to it is a 12x2, then you have a 16x2 and you have a 20x1. You may have seen this at various locations, and we are going to use this in our experiment. Now, one could create a mechanism for connecting such a display to a microcontroller, and the most common interface for connecting such a display to a microcontroller is what is called as Hitachi HD 44780 LCD controller. This has become a de facto standard for character LCD displays, which span the entire range from 8x1 to 20x4. It has a common interface as we see here. This is the interface, that it requires certain pins for sending information and reading information from the display, for providing power supply to this display, for providing power supply for the backlight, the source of light which we are able to stop or allow to come out of the LCD, that is the light we were talking of initially, and this has been available for a very long time. In this display, the one we are going to use in our experiment, we are going to use a 16x2 LCD display. This is the most common display that is available, and therefore the cheapest that you can find. The 16x2 translates to 2 lines, and each of the line allows you to display 16 characters. Each character can be displayed in a 5x8 matrix, which means that 16x2 LCD, how many pixels it has? Let us calculate that. A 16x2 LCD, where each of the displays, each of the character is 5x8, that means 40 pixels. Therefore, the total number of pixels on a 16x2 LCD is 32 into 40, and that is a large number of pixels that you have. Now, obviously, to be able to control each of these pixels is equivalent to controlling so many LEDs that we have seen in a previous lecture, and the only way to achieve this is by way of multiplexing. Except the responsibility of multiplexing is not on the microcontroller. The LCD has resident microcontroller or a single purpose computer which is doing that job on our behalf. All we have to do is send information to the controller that what do we want to display, and this information, this interface that we were talking about basically allows an external controller such as MSP 430 to communicate with the resident single purpose computer on the LCD display, convey information to it, so that that controller is able to multiplex all these LCD pixels to display whatever information that the user may want to provide. And the Hitachi controller HD44780 offers a unique and uniform interface which has these 8 data lines, some control lines like these and these, and a power supply here, a power supply for the backlight and a contrast control. Using a 16 pin interface, any microcontroller such as MSP 430 or any other microcontroller can display information in a uniform fashion. And it does not matter that you have a 16 cross 2 LCD, you can also have a 20 cross 4 LCD. Even then the interface to the LCD will remain the same. That is the beauty of this Hitachi HD44780 LCD controller. Okay. The pinout, let us go through the pinout of this LCD controller. The most important part is what is the power supply required. The power supply that you require is here, ground and VCC, and this is the commonly available LCDs require 5 volt. Of course, 5 volt does not mean 5 volt, usually it is 5 volt plus minus 10%, which means you can have a supply voltage from 4.5 volts to 5.5 volts. Apart from that, you need to set the contrast, and I will share the circuit that you have to connect to be able to adjust the contrast of the LCD. Apart from that, you have data pins D0 to D7 as you see here, and control signals which is read write, enable and register select. These are the 3 control pins that you require for communicating with a common LCD display. And then you have 2 LEDs, 2 pins of an LED, anode and cathode, which provide the backlight to this LCD. These LCDs are available in many colors like green color with black segments or any other color, and you can choose whatever is available for you. Now these are the description of the pins. You have a read write pin. If the read write pin is 1, that means you want to read internal register. If you set this pin to 0, that means you want to write into that register. You also have a enable pin which is like a write, it is like a chip select. You have to keep this signal low to be able to a negative edge on this signal, which indicates to the LCD controller that you are writing something. Then you have a contrast adjustment on one of the pins. You have 8 data pins D0 to D7, and you have a register select. You have 2 registers, one is for command and the other is for data. So if this value is 0, that means you are sending information to the command register. If this value is 1, that means you are sending information to the data register. And apart from that, you have 2 pins which are the anode and cathode of the backlight LED. Now to create a uniform interface, the Hitachi LCD controller offers a set of commands, and any controller can send these commands and the Hitachi controller will react appropriately. At this point, I would like you to take this LCD that you have in your hand and flip it around and see what is behind that LCD. You will find 2 black dots, and those black dots are what are called as chip on board. Underneath those black dots are ICs, which are the controllers and the memory for this LCD controller. Okay, so these are the commands. What commands you send? You can send a command to clear the display. You can send a command to return to home. Home means the initial position of the cursor. You can increment or decrement the cursor. You can go forward or you can go backward and so on. So there are about 20-25 commands here, as you see, 21 commands which allow you to interact with the LCD controller. Some of these commands we will see when we do an exercise. Let us go towards that. Now, one of the problems with the LCD 16x2 or any other character LCD is that it works at 5 volts. Here it works at 5 volts, and so we have this issue that our MSP430 lunchbox operates at 3.3 volts, but the LCD works at 5 volts. Now, how do you provide 5 volts? So, in this lecture we have offered you several ways of creating 5 volt supply so that you can power your LCD, and the first method is to use a modify a USB cable that you may have, or if you search the internet you can get access to what is called as a breadboard power supply, a small module that will fit into the power supply pins, the side pins of a breadboard easily, or if you have access to a lab power supply you can set it to 5 volts and you can use it to power your LCD also. I will come to that in a brief moment, but let us go back to the interface of the LCD. Now, because you have 8 pins for interaction, the LCD the controller inside the LCD expects you to send commands over these 8 pins, but oftentimes we do not have 8 pins. The Hitachi interface is very benevolent in that sense that it will adjust to sending information on 4 bits also. Instead of 8 bits you can communicate with the LCD controller on 4 of the 8 pins, and that is called the 4-bit mode. The default mode is 8-bit mode, but if you like, if you do not have pins you can select the 4-bit mode. In fact, one of the commands, as you see here these two commands allow you to communicate to the LCD that no, we do not have 8 pins to communicate to you and we are going to send information on 4 bits also. So, you have to send these commands, and we will see briefly how you send these commands. So, you have a 8-bit mode and a 4-bit mode. Now, in the 4-bit mode, the actually information is being sent, you want to send 8 bit of information, but because the communication connection only has 4 pins, you have to send information on those 4 pins twice, so that you can send entire 8 bit of information. So, you have to tell the controller that we are going to send 4 bits and then another 4 bits, the lower nibble and the higher nibble. And the way to do that, here is the sequence of instructions. You send the information like this and say you send a value called 33. 33 is in hexadecimal, then you send 32 and then you send 28. When you send these 3 bytes, it conveys to the LCD controller that you want to communicate with the LCD controller in a 4-bit mode, and you want to have 2 lines, and each of the line will have characters which are defined as 5/7 matrix. And then these are additional commands where you are turning the cursor off and you want to have the increment cursor automatically, and you want to clear the display screen, that any previous information is cleared off. But the most important is that you want to send these 3 bytes of information to the controller, but you do not have 8 bits to send, 8 wires to send, you are sending it in chunks of 4 bits each. So, we will see when we look at the code for doing this, we will see how we achieve that. These are the connections you will find on a character LCD. You have anode and cathode which are for the backlight LED. You have these 8 data lines, and if you so wish you can choose not to use 4 of the lines. So, you see this 4 lines D0 to D7, D0 to D3 are not being used, and you can only use 4 pins, and the numbers that you see here are, they refer to the port pins of MSP430. So, we are going to connect P1.4 to P1.7 to send data. We are going to use P1.3 for the enable signal. We are going to use P1.2 for the register select, and we also have read and write, and we have permanently grounded it. What does it mean? That we permanently want to write into the LCD, we do not want to read any information back, that saves you 1 pins. So, with this you are able to using just 6 pins, 4 for the data and 2 for the control signals, this one and this one. With the 6 pins available on your microcontroller, you are able to control a LCD. Apart from that, you need a contrast, which is achieved by having a 10 kilo ohm. This is a 10 kilo ohm preset, where you adjust the preset to give you the contrast that you want, and then you leave it there. And this is the supply voltage 5 volts, but of course 5 volt plus minus 10%. These are the connections that you require, that you need to make and connect it to your microcontroller, in this case MSP430 lunchbox, to be able to send information and display that information. Now coming back to the power supply requirements, since our MSP430 lunchbox does not have 5 volt available easily, we have to find a mechanism to provide 5 volts. One option is that you take any USB cable, whether it is a micro USB or a mini USB output, plug it into your power bank or onto your laptop, and on the other side you can cut it and select appropriate wires to provide 5 volts. And in this PPT we are going to show how we can do that. So, here is the, you take a USB cable like this, cut one side off, this is the cut side, then you strip it off and you will find that inside there are 4 wires. The 2 of the wires are yellow and black, red and black, and that is the power supply plus 5 and ground, and then you have a copper wire which is like the shield, and then you have 2 more wires, those are for data plus and data minus. We do not need them in our application, so we are going to cut them off. Then you cut them off at different length. The black and red wire you keep of the maximum length, and the other 2 wires, this one and this one, you can cut at different lengths, because you do not want to short them, because that may give false information to the cable where you are connected it. Then leaving the black and red cable, you bend the rest of the 3 cables and then you tape them off like we see here. Use a insulating tape, tape it off. Now these wires can be cut at different lengths. Why? Because we will see, we do not want them to be of equal length, they may short with each other and they may create problems for the USB interface. So, you cut them at different levels. Those cut wires you tin using a solder wire, you apply solder onto it, so that the braids of the wire are all joined together. Then I suggest you use a resistor on the positive wire. In this case, this is a 47 ohm resistor. You can choose any resistor up to 20 ohms. The reason is, if inadvertently you short these 2 pins, the resistor will limit the amount of current that can flow in this circuit, and the safe limit for USB, normal USB is 500 milliamperes. Till 500 milliamperes it will not damage the USB port. So, we have put a 47 ohm resistor, that means we are allowing up to 100 milliamperes of current, and this is suitable and sufficient for our LCD. If you have a lesser value resistor up to 20 ohm, that is suitable. So, you can choose a 22 standard ohm up to 47 ohm resistor like this, and this once you solder on the 2 wires, it provides you 5 volts that you can use safely to power your LCD. Now, here we are looking at the Hello LCD code. This is the code we are going to write on our Code Composer Studio. We are going to build and compile it, and we are going to download it into our lunchbox, and we will see here which connections we have made to the LCD. Let us go through those connections. So, these are the pinouts. The LCD output we are going to take out of P1. So, we are making it P1. The direction is set here, that they will all be output, and these are the 4 bits of data. As I mentioned, we are going to interface the LCD in a 4-bit mode. So, we have 4 bits, bit 7, 6, 5 and 4, and the register select and enable pin are going to be derived from P1.2 and P1.3. Okay. Now, we are going to come here later. Let us go back to our main program. So, basically what you need to do is, using this pinout, you need to connect your MSP 430 microcontroller to the connections of the LCD that we have seen earlier. You need to also connect the 5 volt and ground. You need to connect a potentiometer between VCC, that is plus 5 volt and ground, and the center of the potentiometer or the preset you need to connect to the contrast pin of your LCD. Apart from that, these 4 data pins, the register select and enable pin, you need to connect to the port 1 pins, and the other pin that we mentioned, RW pin you need to connect to ground. So, once you make those connections on your LCD, which you can insert in your breadboard, you are ready to go. Let us see the main program. So, the main program starts here. Here the main program is actually very simple, but that is because most of the functionality has been outsourced to in the form of functions. The first thing that we do the moment we enter into the main program is that we disable the watchdog timer. We do not want the watchdog timer on our MSP 430 to interrupt us. Then we call a subroutine to initialize the LCD, and then we set the cursor to the home position, that is 0 1, which is the top left pixel is our home position, and then we want the LCD to print a hello embedded on the first line, and on the second line we want to print systems, and then we are going to wait here in this doing nothing. That is the main code. Now, let us go through each of the functions and see what it does. Let us see what LCD init does. So, LCD init, what it does is it initializes the port 1 pins to be output, and it sets the direction as output, and it defines them as output. This is what it does, and it makes all the pins equal to 0. The register select is 0, the enable is 0, and all the data pins D4 to D7 are set to 0. Then it calls a delay of certain amount, which we will see what it does, and then it writes a value called LCD write here. Let me erase this. It calls a function called LCD write, and in that LCD write there are 2 variables, 2 parameters. One is a number called 33, and then it says that this number should be treated as command. Now, you remember the LCD is able to accept either command or data using the register select function RS. If we are sending a command, that value has to be 1. If you are sending a data, that value has to be 0. You are basically conveying to the LCD write function that this value, this number 033 0x33 hex should be sent as a command. Then you are delaying for some more time, and you are sending another command with the value 32. Then you are delaying for a lesser period of time. Now, you are sending these 4 commands. Basically, as you can correlate with the commands that you can send to the LCD, this is allowing you to initialize the LCD in 4-bit mode with 2 lines. You want the cursor display to be on, you want the cursor to be off, and you want the cursor not to blink. And then you clear the screen using this command. After some delay, you are setting the cursor for auto increment, meaning when you write one character, you want that cursor to go to the next character. And initially you want to set the cursor to 0 0, which means in your display here this is one line, this second line you want it to go here. This is the initial location. Once you have initialized the LCD, you are executing the second command where you are saying set the LCD cursor to 0 1. So, let us see what that command is. LCD cursor here. Here you are sending some information which uses the same LCD write. You are sending this information, and you are sending the offset of the values to the LCD, and then you are delaying it for some time. Let us go back to the program. Then you are saying hello embedded. You want to print this information, you want to print these characters onto the LCD. Let us go back to LCD print, what it does. Now you are passing a array to the LCD print and you are passing its pointer. So till the pointer does not give you a null, because when the pointer ends the value is null, till the null value is received, you are sending information and you are saying that this information should be treated as data. What does it consist of? It consists of these characters under in the apostrophe is hello embedded. So you are sending one byte at a time to the LCD write function here. So let us go and evaluate the LCD write function. Here is the LCD write function here. In the LCD write, before that let me mention here that in our program we have chosen to use a variable of the type uint8t. This means unsigned integer of a size of 8 bits, which is not very different from unsigned character. But this is not available in your normal MSP430 header file. For that you have to include a different header file, and that is this int types. In int types there is a definition of how to invoke uint8 kind of variables. So we have used that. So LCD write requires two values, one is the value and the other is what is the mode, meaning in what mode should these values be sent to the LCD. So this mode can be either command or it can be data, and whatever value is there it will be sent, but this value will be 8 bits, but as we know we are not able to send 8 bits of data from the controller to the LCD, we are sending 4 bits at a time. So this LCD write function will actually split the 8 bits of the data that you get here and split it in 2 nibbles and send one at a time. Let us see how it does that. So first of all it says that it is going to generate a low command on RS for command mode. So it is going to generate it is going to pulse like this, making this using this command it makes RS 0 and using this command makes RS high. Then it is going to output the two values which is there in the value here. You are going to take the upper nibble by ANDing it with F0, and the original LCD out value you are retaining the lower values, but the upper values you have made 0 by ANDing it with 0f, and that value is being ORed with this information. And then you provide this value onto the port 1 pins, that is LCD out. Then you pulse the EN pin which makes the LCD controller receive this information. Then you delay for some time. Now you are still left with sending the lower nibble. The value in the lower nibble is shifted to the upper nibbles, ANDed with F0 so that the other bits are 0, and same function you operate here and create a value to be sent to port 1, and once you send it to the port 1 you pulse the signal on EN and then you delay and you go back. And what does pulse EN does? It does nothing, but it creates EN equal to 1 and then it makes 0. So these are the sequences of operation that LCD the controller needs to perform so as to send information to the LCD. So I recommend that you download this code, build and compile and download it into your MSP430 lunchbox. Make the connections to the LCD as discussed, and this is what it would appear, that you have made appropriate connections to the LCD, and when you run the program you will see that the LCD prints this message. So this is one part. Now the LCD is capable of creating custom characters also. These are all built in ASCII characters that it is able to print. But what if you wanted to print a smiley, something like this, or a heart, something like this? It is possible to print the heart like this by creating a pixel character. and store this information in the RAM that the LCD has, and then invoke them so that you can print these characters. So, the second part of this code we are going to show how we can create custom characters, store them in the memory of the LCD and then invoke them and tell the LCD controller to display them. The information can be stored in a RAM that is available on the LCD, that is called custom graphics RAM, and that information, that size is, you are getting 64 bytes. For each character you are getting 8 bytes. Out of these 8 bytes, as we see here, out of these you can have 8 characters, each character requires 8 bytes. Out of these 8 bytes you are ignoring 3 bits because your character is 5 by, it is 5 columns and 8 rows. So, you can specify into this 5 by 8, or you can think of it as a 8 by 8 RAM, which of the bits have to be 1, and once you write that information you can then invoke them later on, and the first character is stored at address 40 and its address is 0. The second character is stored in RAM, these are RAM addresses 40, 48, they are, as you see, they are all 8 bytes apart. So, you can write information into these RAM locations, and once you have written, you can invoke them by sending information to the LCD that you want to display the character stored at address 0 or 1 or 2 and so on. So, I strongly recommend that you go through this code. It is not very different from what we have discussed earlier. The only addition is that we have stored custom characters. In fact, we have stored a hearty, we have stored a heart like this in the CG RAM, and you can invoke it and display this into your display. So, I strongly recommend that you go through this. The codes are very well documented. Reading it will tell you what we are doing, and once you connect, the connections are not very different. Other than the LCD, you only need to connect a switch here. So, when you press the switch, when you turn the when you download the code, you will see the same hello embedded systems. When you press the switch, you will see that 2 hearts appear around before and after the systems. When you press the switch again, they will disappear, and so on and so forth. So, I strongly recommend that you go through that code. That code is not very difficult, that code is not very different from the earlier code. The only addition is to add custom characters, and that code is quite readable. I recommend that you go through it and use that template for creating your own custom characters and use it whenever your application demands so. So, with this we are at the end of this lecture, where we have illustrated how we can connect character LCDs to your projects using MSP 430, and we will see how we will use it in our future projects. Thank you. See you.